In the next question, I ask you to write a MIPS program to ask the user to enter two integers, a and b, and then display the result of computing the expression a plus 2p divided by 5. So she declared several statement and messages here. These are the messages in her message for number a and b, and in order to display both of the number and messages, she split the output message into some parts, some Western part, and also some numerical part. Here she displayed a message for entering a, and after read it, store it in the variable a, and you are shown another message and read one number by system call number 5 and also a storing variable b. Then, in order to compute 2 times b, she used the shift left logical operation. So by this way, the value of the b will be multiplied by 2 and then load the variable a in dollars and C0 and added with the 2 times b, so till now we have a plus 2 times b. And finally, by divide instruction, she divide this summation by 5 and store the resulting variable result. Also, she print a complex output message, and step by step it's a combination of a string and numerical values printing. Let me show you the output here. For example, when I enter 125 as the NB, the output format is like this one. First the process is printed, then the first value will be print a plus and 2 times. This is a string here. If you check it, she declare it here. And then the second number, 25, and then divide by 5. And finally, this number is 120, 150. And if you divide 150 by 5, the answer will be 30. Okay. In the question number 8, I ask you to convert the following algorithm into MIPS assembly language. As we can see in this algorithm, first I input 2 integer numbers, number 1 and number 2. Then there is a if condition if number 1 by 2 is equal to 0 and number 2 mode by 5 is not equal to the 0. We want to print case 1 else. If the number 1 is positive and number 2 is less than 11, it can be considered as case 2. Otherwise, if the summation of these two number input numbers are divisible by 2, then print case 3. Let's see one of your friend's solution again. These are the messages here. She reads one number and a story in the number, and here she reads the second number and a story. So for now, load them inside the T0 and T1 as the two temporal register, and which is their T2 is equal to 1. In order to compute, the number 1 divided by 2 is equal to 0 or not, she use logical. And so as I mentioned in the question number 2, I think when we add a number by 1, all of the bits of register becomes 0. Only the rightmost bit or the LSB will be remain. So as you know, the LSB for the event number is 0 and for the odd number is 1. So check it after we end T0 by number 1. If the result is not equal to the 0, we should go to the case 2. It means that the number 1 is not divisible by 2, but otherwise we should check the second condition because there is a n between this 2 part. Now we find that this condition is satisfied. Now we should check the second condition. Here we use a division instruction. Divide by 5 and move from high register or remainder part into the teller sign to again branch. If T2 is equal to the 0 to the case 2. So if it is equal to the 0, go to the case 2. Otherwise it means that the first condition is completely satisfied. So we have to print case 1. The number 1 is divisible by 2, and the number 2 is not divisible by 5. So here the case 1 will be printed and we skip the other part. Jump to the end of in case. The last point of the program. So if one of the number 1 divide by 2 equal to 0 or number 2 divide by 5, not equal to 0 is not satisfied. We come to the case 2 and in the case 2. Here we have the second part or second. If condition number 1 is greater than 0 and number 2 is less than 11. So as you can see, this is the element and we check it. If it is, if the number 1 is greater is less than or equal to the 0, we go to the case 3. Otherwise we come here and check the number 2. If it is greater than or equal to the 11, we should come to the case 3. Otherwise, it means that the number 2 is less than 11 and number 1 is positive for this type of situation. I want to print case 2 message and skip the remaining part. And finally here at the number 1 and number 2 to each other. And again, instead of divide by 2 and compute the mode, she ended with number 1 and check the result. If the result is not equal to the 0, it means that actually none of these conditions are satisfied. If the summation is not divisible by 2, it means that we don't want to print anything, and otherwise we print the case message 2. So for the first case, a number should be divisible by 2 and not invisible by 5. Poonam. I'm sorry. The first number divisible by 2. Like 4, for example. And for the next one, not impossible. By 5. Like 13. This is case 1. Okay. Now, let me give some number which not satisfy this condition, but satisfied this one. A positive number which is not divisible by 2. It's enough. For example, 3. And the next one should be less than 11. Like 10. This is a case 2. Okay. And finally, last condition. The number 1 should be art and not greater than 0, for example, or the number 2 should be greater than 11. So let me use this value in art. Number 4, number 1, and 15 for number 2. As you can see, the case 3 is printed and also the summation of this 2. Number 3 and 15 are 18. And since this result is divisible by 2, the case to reprint it. Let me check another one, 3 and 14. Nothing should be displayed. 3 and 14, as you can see, nothing displayed.